Hello, and welcome to the IoT Chat, where we explore the latest developments in the Internet of Things. I'm your host, Christina Cardoza, Editorial Director of Insight.Tech, and today we're going to be talking about what rugged IoT means and how to make it a reality with a panel of guests from ASUS, OnLogic, and Crystal Group. But before we get into the conversation, let's get to know our guests a bit more. Jason, I'll start with you. We have Jason Liu from ASUS. Can you tell us more about yourself and the company?
Sure. Hi, everyone. My name is Jason Liu. I'm the product director for ASUS IoT. ASUS IoT is a new business unit under a new business group called AIoT under ASUS. And we focus on industrial PC for embedded applications. I'm very happy to have this opportunity to meet you guys. Thank you.
Yeah, absolutely. And obviously, industrial IoT there, that's going to be a big conversation today when we're talking about rugged IoT. So before we dive in, David Zhu Grant from OnLogic, welcome to the show. Please tell us more about yourself and the company.
Yeah, thanks for having us on. So David Zhu Grant here. I'm a senior product manager here at OnLogic. We're a global company that designs and builds our own industrial and rugged computers. We have a real emphasis on supporting our customers. So the customers tell us that they like our high quality products, customization capabilities, and excellent sales engineering. We really want to build that trust with customers. And I think it's really important in this rugged IoT space. So customers can kind of advance their ideas with OnLogic. So thanks for having us on.
Great. Yeah, the pleasure is all mine. And last but not least, Chad Hutchinson from Crystal Group. What can you tell us about Crystal Group and, why you guys are part of this conversation today?
Well, thank you for having us on. My name is Chad Hutchinson. I'm Vice President of Engineering here at Crystal Group. We focus on bringing commercial off-the-shelf electronics, servers, and displays, and switches and things of that nature into environments for which they were never designed to meet the needs of shock and vibration, high temp, and those things. So bringing IoT into the field is one of the things that we specialize in.
Yeah, absolutely. And like you said, sometimes these devices are brought into environments that they were never designed for. So as more businesses, want to take advantage of all the benefits and advantages and capabilities that the Internet of Things has to offer, a lot are finding that the traditional devices, aren't well suited for, like you said, in the environment that they want to use them in. There's a lot of other conditions and concerns that they have to worry about that, maybe challenges them and limits them to take advantage of IoT. But with companies like yourselves, with rugged IoT devices out there, it's making it possible. So, Jason, I wanted to kick the conversation off with you today. If you could talk a little bit more about, when we say rugged IoT, what are we talking about? Why it's important to businesses, and what's the significance of this?
Yes, kind of mentioned earlier, IoT devices are deployed in different environments, and more devices are coming online. But in lots of cases, right, they are hotter or colder temperature that the devices need to operate within. One example, like in McDonald's, a drive-through would need to survive below zero and in wintertime, and the temperature inside that display enclosure can go as high as 70 degrees Celsius during the summertime. And like the outdoor display that you see the menu right now, a lot of them are the LCD, right? They would also need to be waterproof for snow or during the rain. And you also see a lot of touchscreen being used for user input. In the outdoor, the water drop may cause force touch and trigger some operation that you don't really want, right? So in this kind of operating environment, a ruggedized IoT devices are designed to operate in that kind of environment, survive the cold and the hot temperature. And then in a vehicle application, for example, shock and vibration now become very, very important, right? Usually with the fan, if you keep in that environment, keep bumping on the vibration, it will fail very quickly. Then you have to send a technician. So a lot of use cases, you would need to go to this more ruggedized design from the beginning. This way, the device will be able to survive over the life of its operation. So it's important to kind of take that into consideration when you start a new project.
Yeah, and I love that example, sort of with the drive-through, because I think that is something that we've all come across. We've all seen these devices out here, but you don't really think about what goes into making it work. And they're becoming very intuitive these days. They're changing based on the day it is, or what you're ordering, or maybe sometimes they're personalized to your preferences if you're a repeating customer. So it's interesting to see what goes on in this, because a lot of times, it's raining. There's reasons why we do go to the drive-through, and if these aren't up and running, then you can't really serve your customers. But David, I'm wondering, what other types of industries or businesses do you see trying to leverage these IoT devices? If you have any other examples you can tackle on to what Jason just said.
Yeah, definitely. And I think Jason hit the kind of the why. It is a pretty broad spectrum of industries that we've found you see these rugged IoT devices in. Kind of categories or industries like manufacturing, warehousing, logistics, smart ag or agriculture, smart city, mining, and energy. And that's because these industries have those environments that kind of Jason alluded to around temperature ranges, very cold, very hot, vibration impacts or shock on vehicles. And then one other one would be they can be quite electrically noisy as well from a radio frequency emissions perspective. So big, machinery turning on and off, that can also be a big factor for these devices. So those industries kind of capture those challenges for devices.
Yeah, absolutely. And I think, in addition to there being like the environmental concerns, like you mentioned, there's other concerns outside of the environment. Computing is getting more intensive. Everybody wants high performance. That's putting more pressure on these devices to operate. And Chad, I want to go back to something you said in your introduction, which really kicked us off. These devices that we have been using today, they weren't really made for environments that industries like manufacturing or some of these other businesses are looking to bring them into. So, what have you seen from Crystal Group? What's been the challenge to deploy an IoT device in some of these, call them harsher environments?
Yeah. So in industrial applications, the things that we see are primarily sand and dust. So some of these environments like mining, you have a very fine coal powder that is going to get in places that can interrupt your cooling. Can also interrupt electrical connections, get into nooks and crannies in places that they really shouldn't. Some of these things are very conductive because they're metals, and that can cause shorts. So that's one of the issues that you're dealing with. In the field, cooling is an absolutely huge issue. When you look at all electronics are having more and more computations, generate or consuming more power, which means that they're generating more heat, makes the thermal challenge and the ability to cool the environment very difficult. As Jason pointed out, some of the temperatures can be upwards of 70 degrees C in the environment, but also you would think that electronics wouldn't mind being in a cold environment, but if you get down to 40 degrees C and below, electronics, commercial electronics, don't want to operate. They don't boot properly. Voltage regulators don't function correctly, and that can cause some serious problems there as well. So that's in the industrial or commercial markets. But then you have naval maritime type environments where you have salt fog. That can cause problems. High humidity environments in both the industrial and maritime environments. We do see these things deployed even in oil rigs, right? So that's a very dirty environment, but also a high moisture environment. And then I think David pointed this out regarding the EMI perspective is a big issue. But one of the other big challenges that we run into is actually the power interface. So generally, IoT devices are designed for being in an office environment or someplace where you have a good regulated input voltage that's held within a tight tolerance, and generally doesn't have interruption. Whereas out in the field, you may not have 120 volts AC like we have at the outlet of our home or our office. Some of these places have 28 volts DC. Switch yards having 125 volts DC is their common switchgear power. Aircraft is 28. Automotive, 12 volt DC distribution. And generally, these devices are not designed to take that input power, but also there's voltage transients by nature of those things, starting surges that pull the voltage down. So In many cases, you can solve these problems with a voltage regulator or a power conversion device in between, but those things can add an additional reliability challenge. So those are some of the challenges that we find in trying to bring a commercially available IoT device that has great technology, great functionality that it's bringing to the table, but trying to deploy it in the field.
Yeah, absolutely. And I want to come back to some of those practices you said to sort of get over bringing these devices out in the field, how you can be successful. Before we get into it, you're right, these devices were first designed and thought of to be in like an office space or somewhere where the environment doesn't change very often. And when we think of rugged IoT, it's often bringing these out in the field, making sure that they can handle and withstand all the environmental concerns. And like you mentioned, like in mining environments and other areas like dust, just everything that needs to be considered. But there's also, David, you mentioned like bringing it into the factory and manufacturing. There's also these industrial environments where you are still indoors, but there are still those temperature concerns or other concerns you need to worry about. So can you talk a little bit about when you're not out in the field, what are the other environmental challenges that some of these factories or other businesses and industries need to worry about, even though they're indoors?
Yeah, exactly. So I think some of these environments, you kind of call them non-carpeted environments. So they're still indoors, but they're not like an office sort of environment. And they still suffer from the same sort of challenges. So you still see temperature extremes. They're often not air conditioned, so you can get very cold, very hot. Airborne, particularly, it was mentioned before. And sometimes it can be conductive. Sometimes it can be dust. That can really impact cooling and also reliability from circuit board perspective. I think the other one I mentioned was electrical interference, and that's a big one. So a lot of these warehouses and factories have big either air conditioning units or big machinery that start up or stop, and that can cause a lot of EMI issues that can need to be dealt with, and it's a bit of a challenge for these devices. And then also being indoors, you still have to deal with those factors for reliability and long term. So this is not just a temporary interruption; it can also be a reliability issue long term. So if they're staying too hot too long, your computer's not going to last. And so that's kind of a factor. Long-term reliability in these indoor environments is still a factor.
Great. Now we've been talking a lot about the challenges for IoT devices out in the field in these more rugged environments, but I want to dig deeper into now that we know the challenges, how do we overcome the challenges? How can we create these devices to withstand these environments? And Chad, you started talking about some of this, so I want to start with you there. How can we design technology and the hardware to survive in sort of the harsh environments, whether it's out in the field or in a factory?
Well, from a mechanical perspective, shock and vibration, you really have to prevent any differential movement of the circuit cards from one another. Most computers these days have cards plugged into cards, things of that nature, and those are target places where dissimilar movement causes problems. Also, when you have flexing of the printed circuit board, that puts repeated stress on the solder joints. So if you can stop or prevent that movement by a really rigid chassis, that can help with shock and vibration. When you talk about things like humidity, salt fog, even fungus, believe it or not, that's actually something we have to deal with. You're really trying to put a barrier between the outside world and the electronics itself. And that's generally a coating, a conformal coating of some kind that's providing a barrier, that's an insulating barrier that prevents that contact. Heat is a big challenge. When you have high temperature, you're looking for cooling sources, whether or not you could put more air across something. Heat sinking components that weren't originally heat sunk. Some things are open to air but don't have a heat sink, a formal heat sink on them. Converting to liquid cooling and plumbing in a source of cooling water is another thing that you're seeing in electronics these days. The power distribution or immunity is typically dealt with by input filtering on the front end that will address or prevent spikes and things of that nature from interfering with the supply. Brownout situations where you have voltage dip, you might actually use a capacitive bank, or some cases you'll use a UPS that is a battery backed source to address those issues. So in short, you look at each and every one of the factors that the environment is affecting the device, and you knock those things down one at a time. And for each of those things, the industry has pretty much found a way to solve those.
Now, I'm curious, Chad, because when we talked earlier in the conversation, talking about how these devices weren't made for these environments, and now we're talking about some of these capabilities that we can add on to ensure that these devices can withstand these environments. But I'm curious, what is the approach that businesses are doing this? Are they adding some of the capabilities and advantages, like you just mentioned, onto their existing IoT devices and applications that they have, or are they building something specific designed for the application and the environment that they are in?
That's an excellent question. When businesses are looking at IoT, in many cases, they're looking at the functionality and capability that it brings to the table. It's allowing, monitoring of some equipment and a real-time data transfer communication back so we can make decisions and do things with that information. In the first piece of that, you want to look at the capability that the device brings to the table, and you want to look first to the commercial environment, because that's where the technology refresh cycle, the latest cutting edge, is going to be, primarily because that's where the big market is things for the mass market. If you can find an item that is commercially available that has the functionality that you need, you want to go off and look to deploy that, test it in the environment, and see, in what ways does it not perform. Identify those things, and if it works for you, provides the functionality and lasts, then you're probably done. In other cases, you may identify that no commercially available item has the functionality that you actually need for your application, in which case you're into a custom solution right from the get-go. But let's assume that the commercially available item can meet your needs, but just won't survive in the environment that you have. And that's when ruggedized or militarized commercial off-the-shelf electronics can really come to play at a more reasonable cost, albeit higher than COTS alone, considerably cheaper than a pure ground up custom solution. And that's where you start going through and identifying only those functions of your specific environment that are causing you a problem. If humidity and sand and dust are not really an issue, then you don't add coatings and things of that nature. If temperature is not really an issue and it's really just a power issue, you look primarily on bolting on the corrective or protective functions that are necessary for your application. And if you follow that type of an approach, then generally you end up at the most cost-effective solution. There are times when you do look at the environment and you realize that we're at the limits of what we can do to make a commercially available product survive in the environment. And if you get to that point, you are really in a more custom application-specific design.
Yeah, and I like what you just said there. You want to be able to find the capabilities, like for your needs, be able to find what's out there and not adding too much to make it more cost effective. So, Jason, I'm wondering, how you've seen companies and customers add some of these capabilities, especially when they're making these investments and we're thinking about cost. A lot of businesses want to make sure that the investments that they are making not only meet their needs today, but future proof them. They're looking out to the future, what needs they may have or what needs they may come across that they don't know that they have. So how can they ensure that these improvements and capabilities that they're adding on or that they need can continue to evolve and scale with their needs?
Yeah, like the chat mentioned, right? This needs to be planted in the very very early stage. A rugged device, of course, will be more expensive from cost or even development perspective. So the first, the solution needs to work under the intended operating environment, right? You want to make sure that it will survive and then will not fail over a long period of time, especially for IoT devices. They tend to operate 24/7. So you want to make sure that the product that you're going to be deployed is going to survive, for the planned operation duration. And in order to achieve that goal, a design review and validation will be longer, right? Usually it's not like you go out and purchase an Office PC, you shop around and probably kind of pick the one in, I don't know, in Costco and bring it back. This one, you do need to plan, validate, make sure, it meets your requirement. Um, For example, you may want to see, you want to do this compute more locally, or you want to kind of rely on the cloud. If you want to do more compute locally, that means you're going to bring in more compute power, and then you're going to have more heat. Then you have more operating temperature you need to deal with. But when you put this more on the cloud, then the connectivity, the reliability of that connection is something that you want to take consideration as well. So this needs to be kind of well planned ahead, and then you decide what you want to accomplish. And then during the development, then you can start thinking about, you want to build this in-house or you want to outsource it. Commercial off the shelf usually can be more cost effective, but then again, you are relying on a supplier to supply that piece of solution to you. Would they keep it longevity that you can purchase even 5, 10 years from now? And that sort of a consideration is more from, build or buy kind of decision. And then during the operation, right? How do you want to maintain it and provide service to the devices? Um, you want to consider remote update capability, or even sort of hardware upgrade consideration. So because of the time it would take into development validation, so the initial cost usually will be more, and and then you kind of want this to be operate, the longer the better, and you don't spending the will to do the engineering effort. So once you take all this into consideration, then you can start thinking about whether the return on investment can be justified. For example, like the kiosk. If this is an indoor environment, a regular fan-based commercial PC might work. But if this kiosk is going to be outdoor, then most likely you have to go to the rugged route, even though that's going to be more expensive. But in terms of the operation life cycle, that will keep you running for the longest time. So with those of consideration you taking, early on during the design phase, will be able to kind of justify your investment in the long run. Yeah.
Yeah, absolutely. And those are some great, considerations and recommendations you should be thinking about as you go on your way. So I'm curious, Jason, do you have any real world or customer examples that you can share with us to help us visualize this a bit more? How you helped your users really realize the benefits and get rugged IoT a reality, how you helped them, what their challenges were, and what the results they saw were?
One example, actually a good example that I can share is a robotic arm in a recycling plant. So the recycling plant, now they deploy robotic arm to do the picking, sorting and picking, right? And you can imagine that's not a very friendly operating environment to the computer, especially the dust inside that they get dirty very, very quickly. And traditionally, because they want to use a robot on the pick, they are doing AI vision compute as well. But to do vision processing, you need to use a GPU card in order to be quick enough to react to the conveyor that's kind of taking those plastic going through. So they have to use a GPU, and GPU would consume power and then come with a cooling fan. So it's kind of like a catch-22 situation. In a very dusty environment, you have a GPU, you have a fan, they accumulate very quickly, and then they get defective very quickly. So they put it in an air conditioning enclosure. So it's still expensive to build and hard to maintain because that environment is still not friendly to an air conditioning machine. So what we did is actually we developed a totally fanless solution for a very high performance CPU and very high performance GPU. Totally, we're talking about 300 watt, but we put them in the fanless chassis. So now you have a machine that's inside a big metal aluminum enclosure with a lot of the fins sticking out. Uh, it's heavy, but once you deploy, you cannot deploy it, you can forget about it because it's a fanless design. It doesn't care about the dust. and then the operating temperature within that, not totally outdoor, but still you don't have air conditioning. So right now that project is in the DVT phase. So the customer is very excited to see that kind of machine working in the field. So once they start deploying this, I think from a operating maintenance perspective, that will relieve a lot of, rolling the truck kind of situation from the operation perspective.
Yeah, absolutely. And as we're talking about, making sure you can future proof or, validate your investments, I also think, once you see the success of one project where, like the robotic arm in one area of manufacturing, you can start building on it and bringing more of your devices to these environments. David and Chad, I'd love to hear from you guys, how you're helping customers, some examples, if you can provide any. I'll start with you, David, from OnLogic, how you guys have been helping the end users.
Certainly, yeah. We've got one really good example, which is in kind of like the mining industry space. It's a company called FlashEye. And so they use LiDAR, which is kind of laser ranging or laser scanning technology to detect anomalies and prevent stoppages and malfunctions and accidents within that mining materials transport application. So this specific example was actually like a belt, and you think of like a conveyor belt with mining materials, rocks, and so forth going down it. And they've built this really smart solution that uses computer vision again. So the AI-based sort of looking at what's happening with the rocks and the flow and the belt, understanding spillage on the sides, and then also further outside of that, whether the people are in like dangerous zones. So all doing that all simultaneously. And the system's also located in a really harsh environment. It's a mining example anyway, so there's that dust element to it. But it's also in northern Sweden, one of the examples. So basically Arctic conditions are really cold and all this other dust and vibration and debris going around. So really harsh environment. They needed a computer that's going to be rugged. So obviously they picked an OnLogic computer, but the overall solution's been so successful that's actually won them some awards, innovation awards in the mining industry. So, really reducing things like accidents, making it more safe, and basically improving efficiency so they can have less downtime when those belts are damaged or there's an issue there with the material flow. So we thought that was a really good example of using a rugged, device out in the field, and specifically with this kind of emerging AI space as well with computer vision. So.
Yeah, absolutely. And I love that example because, it's not only about the rugged IoT device, like you said, it's really an end-to-end solution. Sometimes, you guys are making these changes to withstand these environments, but there are other benefits and improvements and enhancements that you can get by doing this. Chad, wondering if you've seen that, similar things with your customers or how, you're helping your customers bring these devices to rugged environments.
Yeah. So I think Jason had a great example regarding the thermal challenges that you have in trying to bring a GPU into a field application. They generate a lot of heat. So my example is an autonomous vehicle application that we did, and that customer had gives a computer using LiDAR, radar, and sensors to have computer vision and figure out the picture for the driving scenario and whatnot. So it needed some considerable computer horsepower out in the vehicle itself. Challenges were primarily thermal, obviously, with multiple GPUs and trying to get that heat out of the automobile, and shock and vibration. But then also, power interface, because generally computers, servers, IoT devices, they're designed to operate on 120 volts AC. And as I mentioned before, an automotive is a 12 volt DC system, but also during a starting surge, that voltage can actually get pulled down to 9 volts. So it can be really, really difficult when you're dealing with as much power as in excess of 2 kilowatts of power being drawn from an automotive type application. So we designed a custom power supply that was designed for the specific environment of 12 volts DC input with an ATX power output, which then interfaces with your commercially available motherboards and commercial off-the-shelf electronics. Likewise, with the GPUs, custom heat sinks that were liquid cooled and got that heat away from the device and allowed you to get it to the outside of the cab of the vehicle to an external radiator so that you can exhaust that heat. So, and then shock and vibration, of course, we've dealt with before in terms of a very solid a stiff chassis that protects the electronics from that movement. So it's a very interesting project, and it's working very well out there in the field for the customer.
One thing that I like about all of these examples you guys provide is obviously we've been talking about the devices, the hardware, the embedded devices and computers that, it takes to bring IoT to rugged environments. But there was also an aspect, like David, you mentioned, like an AI or computer vision aspect to all of this, in addition to hardware. And I should mention the IoT chat and Insight.tech as a whole. We are sponsored by Intel, but we see a, ongoing theme within all the articles and partners that we talk to, just this better together. No one company can really do this alone. And when we're talking about like rugged environments and getting the hardware up, there's also other aspects, other technology that goes into making this all successful. So I'm curious, how you guys work with partners like Intel, to make some of these things that we've been talking about happen. David, if you want to take that one.
Certainly, yeah. So obviously, our hardware is a really big part of it, but the kind of software layer and stacks on top of that really unlock the features in the hardware. And I think that's where Intel's been a really great partner for us. So the kind of vPro brand has been really good for us. We've had good examples where Intel's partnered with us and they've helped us connect the dots between the hardware we provide, software that might be software providers, and integration partners. We had a good example where a customer needed some remote management, out-of-band management, and Intel stepped in and gave us the resources and the people to talk to really speak to the value of vPro and how that really helped this customer solve a problem without having to go to really big out-of-band management solutions that the vPro and AMT really helped with. So I think that none of these technologies work in isolation. It takes a lot of these interconnected systems and knowledge to successfully implement a winning IoT solution. And I think that's where working closely with folks like Intel really helps. And I think that ultimately the customer succeeds from that collaboration.
Yeah, absolutely. Especially looking at the robotic arm example that Jason mentioned, you have all of these different sensors and technologies and software going into this to make it happen. So, Jason, is there anything else you can add about, working with partners, the importance of collaboration and, using Intel technology, anything like that?
Yes, ASUS IoT, we develop motherboard and system solution, right? But still based on the CPU developed by Intel and other companies. In the embedded application, so power efficiency is usually the most important factor. Um, the less power the CPU consume, that means you have less heat that you need to deal with. Make it easier to put together a system solution. So Intel's technology is usually on the leading edge, and on top of that, embedded. Once you invest a lot of development validation, you want the product to be available for 7, 10, even 15 years. And Intel is very good in providing longevity support for selected CPU. And that's kind of what we pick those CPU to base our development on as well. And the other thing I would like to bring out is we as a motherboard or system builder, we put together a hardware environment. But on top of that, you also have OS. And then on top of that, customer build their application. The OS level still has a lot of fine tuning that you need to do to optimize the CPU performance. And Intel actually has a lot of their so-called development kit. They put together the recipe that for that particular system, and then they point their customer to a particular hardware setup. With that kind of fine-tune the system, then the application on top of that will be able to utilize the performance that the Intel CPU can deliver. So I think that's a very kind of good collaboration between the companies to provide a solid foundation for the IoT application to build upon of it. So that's something that the customer can appreciate, because that save a lot of time when they are trying to deal with those drivers to get the performance up there. That do save a lot of development time. Yeah.
Yeah, absolutely. And it comes back to the conversation we were having a little bit earlier about future proofing your investments, partnering with a technology partner ecosystem that as the landscape changes, they're also updating and keeping aware of what's going on so that any changes that do need to happen can happen easily, and can scale to really the needs that we have for tomorrow. So this has been a great conversation, guys. I think we are running a little bit out of time. So before we go, I just want to throw it back to each of you guys. If there's any final thoughts or key takeaways you want to leave our listeners with today, because it's been a big conversation, and I'm sure there's plenty more to cover. But is there anything else you want our listeners to take away from this conversation? Chad, I'll start with you.
Thank you. I'll just say that when you're operating at the edge out in the field, you got harsh conditions that you got to deal with. And whenever you're trying to bring any kind of technology to include IoT devices, that you need to be thinking about those things up front as part of your project and figuring out how to deal with those challenges as part of your project development. So do some testing up front. After you've identified your component, do your testing, figure out what challenges you have, and then go do just targeted solutions for those. And I would encourage you to get in touch with a partner who has those capabilities, can bring some of that expertise to bear and help you with your project.
Absolutely. And David, anything you want to leave our listeners with today?
I mean, kind of echoing Chad's points there a little bit. I think if listeners have environments that have been described today in the session, I think it's really important to pick a partner, not just someone that's going to sell you a box, but someone's going to work through, understand the industry you're in, the challenges you're facing, and one that's going to help you guide you to that right solution as well. I think trust is really important. So, partnering with someone that's reliable and trusted from the knowledge perspective, from the quality of equipment that they produce as well, and just the hardware itself. I think for us at OnLogic, we really try and focus on that, the right fit, the right solution, the right support, really looking at helping advance customers, advancing their ideas anywhere, basically. But it's important for customers and listeners to pick that right partner. So I think that's just the key thing I'd probably want to take away from this.
Yeah, absolutely. It's not only about the environmental concerns, but you also want to make sure that you're working with somebody that wants to see, you get over those environmental concerns, but continue to be success and add on to that. So great final thoughts. And Jason, anything you want to leave us with today, or anything you think our listeners should really be thinking about as they go forward with rugged IoT devices?
Yeah, I'll echo what Chad and David mentioned, that usually you would like to work with a partner. So I think that's a very part of a recipe for a success deployment. Just want to point out that I mentioned ASUS AIoT business group. I'm on the IoT, that's more on the hardware side. We actually also have AI, because a lot of IoT deployment also started to incorporate the AI capability. So we do have AI solution that we can provide as well. So hopefully that can be beneficial to the customer that's looking for this type of solutions.
Yeah, absolutely. And I would encourage, all of our listeners, as you guys go look forward to bringing rugged IoT devices into your solutions, or, how this can work for your business, visit ACE's Crystal Group and OnLogic websites to keep up with their innovations and see how you can partner with them to make some of this happen. I want to thank you guys all again for joining us today. It's been a very insightful conversation. And thanks to our listeners for tuning in. Until next time, this has been the IoT Chat.